Inequalities in interval notation. We know an equation is that two algebraic expressions are equal. An inequality, or a simple inequality, is a statement that two algebraic expressions are not equal in a particular way. One is either greater than the other, less than the other, greater than or equal, less than or equal. Now, the solution set to an inequality is a set of real numbers for which the inequality is true. It's noted as an interval. We might talk about x being greater than 2, but we write it using interval notation. And in that case, greater than 2, we would have 2, we would go from 2 to infinity. Intervals that use the infinity symbol, as this one did, are unbounded. They can go on forever. There was no bound. An unbounded interval with an endpoint is open if the endpoint is not included in the interval, and closed if the endpoint is included. But what do we mean about by opened and closed? Well, here we have the set. If we have the set of x such that x is greater than a, the interval notation would be parentheses a comma infinity. That means it starts, this is open, it starts just after the a and goes to infinity. Graphing it, we would start by putting a parentheses at a and going to the right. Now, if we have the set of x such that x is less than a, in this case, a is our endpoint, but we always do the smaller number first. So negative infinity is smaller. Parentheses, negative infinity, and then a, and this is a parentheses because it's just less than, not or equal. This is open, and we have the parentheses. You can see this one goes to the left. If we happen to have x such that x is greater than or equal to a, notice now that we have a bracket with the a. That means the a is included, and then comma, it goes to infinity. This is closed because there is a definite point that it starts. And when we go to graph it, we also use that bracket on the number line at a, and then it goes to the right for greater than. If it's x such that x is less than or equal to a, then the bracket faces to the left and it goes to the left. This is closed, but notice the small part first, negative infinity to a, and then the bracket. If our answer was all real numbers, going from negative infinity to infinity, parentheses on both sides, this is open, and it is the entire number line. These are written with interval notation, and we want to write them with interval notation or the inequality. So this one, we start at -3 and go on to infinity. So this is x is greater than or equal, because of the bracket, -3 for this inequality. The inequality to write for this interval notation, it goes negative infinity forever, so x needs to be less than 4. It's a less than because it's parentheses. Now we need to write these in interval notation. X is greater than or equal to 5. It's going to go then to infinity. The small number would be the 5. It's a bracket because of the or equal. And then it goes to infinity. And infinity always has a parentheses. Here where x is less than -2, it's going to go to negative infinity then. But starting, that's the small, so negative infinity to -2. And this is an open interval because it's just a less than. Now we want to solve linear equalities in one variable. Linear equality in one variable is an inequality that can be written in the form ax plus b is greater than 0, where a and b are real numbers, a not being 0. And the symbols that we have, a greater than here, but it could be greater than or equal, less than or equal, could also be used. Now the properties of inequality. If A and B are algebraic expressions and C is a non-zero real number, then the inequality A, if we have A is less than B, we may add or subtract the same thing, the C, this non-zero real number, to both sides, and the inequality will stay the same. If we can multiply both sides by C, if C is positive, notice the inequality stays less than. But if C is negative, it becomes greater than. This sometimes surprises people, but let's start with a couple numbers. Let's say that 2 is less than 5. Well, if we multiply by 3, we'd end up with 6 is less than 15. That is still true. But what if we multiplied by negative 3? We started with 2 is less than 5. And we multiply by negative 3, we'll have negative 6 and negative 15. And we know that negative 15 is bigger. Negative 6 is larger than negative 15. The same thing happens when we divide. So if we had 12 is less than 14, and we divided by 2, would have 6 is less than 7. But if we started with that same 12 is less than 14 and divided by negative 2, we would end up with negative 6 and negative 7, and negative 6 is greater than negative 7. So you must remember to reverse the inequality whenever you multiply or divide by a negative. Now we want to solve this inequality, answer the notation, and graph the solution set. We start solving just as if this was an equation by subtracting 7 from each side. So we end up with negative 2x is less than negative 12. Now we need to divide both sides by negative 2. X, since we're dividing by negative, it flips the inequality, is greater than 6. In interval notation, that would be 6 parentheses because it's just greater than to infinity. Graphing that, that would become, we would go 6, a parentheses, and go to the right, and that would graph it. Same thing. Well, first thing I wanted, the x is all on one side, so I end up with negative 6x. 3 minus 6x is greater than 8. Negative 6x is greater than or equal to 5. And x will be less than or equal to negative 5/6. Again, we're dividing by a negative, so we had to reverse the inequality. In interval notation, this is a less than or equal, so farthest to the left is negative infinity to negative 5/6, and would have brackets there. Graphing it, if this was negative 5/6, we would have a bracket that opens to the left, and we go to the left, so we have things that are less than or equal to negative 5/6.